Hello, my name's Bob Keeler. I've been involved in industry in general, oil and gas industry, for the last 30 odd years. So welcome to this OGV Innovations podcast. This is a series of one or two podcasts. Today, we've got two very, very interesting companies that I'd really like you to take a look at. The first of these is ReGen Robotics. What ReGen Robotics are doing is they're taking the latest generation of industrial robots and applying it to the murky world of tank cleaning. And the key thing is they've cracked the issue of doing this without ever having to put someone inside a tank. And that's got huge safety benefits. But you'll find out more when you listen to the podcast. The second of this is a company called Safe Influx. Now, Safe Influx have taken a really critical operation from the world of oil and gas drilling, and for the first time ever, they've found a way of making it automatic and making it much more safer. Something that's relied on human intervention since it was started decades and decades ago. They now have a way of automating it with the potential to save many, many lives. Take a look at the two podcasts, the two companies, and tell me what you think. Cheers now. So now I'm joined by Fintan Duffy from Northern Ireland, who runs an organisation called ReGen Robotics, and it'll be interesting to hear what Fintan's going to tell us, because it's a company that I know absolutely nothing about. So, hi Fintan, how are you doing? How are you coping during lockdown?
Good, Bob, and yourself?
Yeah. Listen, there's people that have got many more problems than I have got, but so I'm thankful for what I've got.
Yeah, everyone's just trying to keep the best side out at this stage, isn't it?
Indeed, and at the moment, we're always urging people to stay safe. It's become the kind of what we say to people, okay, stay safe, keep safe. And from what I understand, your product is all about keeping people safe. Go and tell us a little bit more about what you're doing.
Yeah, well, I suppose ReGen Robotics have introduced robotic tank cleaning into the oil and gas industry. The main aim of our product.
When you say tank cleaning, what type of tanks are we talking about, Fintan? Just so that people who don't know the industry would understand this.
So we have two types of robotic equipment. We have robotic equipment for cleaning overground storage tanks, so typical tanks that you'd find in terminals, refineries, that sort of thing.
These would be these big cylindrical things that you see by roadsides and things like that.
Basically, yeah, anything basically from 5 meters up to 105 meters.
Yeah,
we clean them. So that's the overground storage tanks. We have a smaller robot then for cleaning underground storage tanks, which typically are forecourt tanks, that sort of thing. So okay. We offer both. So you will find some small tanks in refineries as well, and we can 9 times out of 10, if we're in cleaning a larger overground tank, we'll be asked to clean a smaller underground tank as well, which we can do with robotic equipment.
So when you put the robotic equipment into the tank, is it on a cable or a tether of some sort, or does it go in autonomously, or how does it work?
Basically, the robotic equipment is hydraulically driven, and it's controlled via a series of cameras mounted on the equipment. So there's zone 0 cameras mounted on the equipment. The operator sitting in a control room outside in a zone 1 or zone 2 location. He's viewing everything on his monitors in his control room, and he can see everything that's happening. He has lights.
So it's manually controlled as opposed to autonomous in that sense.
The larger overground robot is manually controlled. The underground robot is autonomous, where once we lower it into the tank, we set it on a cleaning program for that size of a tank, and it will continue on. Generally, a 40,000 litre underground storage tank takes about 45 minutes to clean, and that's completely autonomous.
Okay, so tell me, what's the big benefit in using this technology?
I suppose the number one benefit, and it's what we have, the reason we've started the company and the reason we're doing what we're doing, is safety. You're taking confined space crews completely out of the confined space. So
how would it been done before your technology is available? How would people clean their tanks?
It was and still is been done by sending confined space crews in. So you're sending people in with wearing breathing apparatus. You're sending them into an environment that you have hazardous gases in. It is a confined space. There's generally only one way in, one way out. So what we're doing is we're sending robotic equipment in. There's gas monitoring equipment on the robotic equipment, so we know what level of gases is in the tank when we're going in there. We can monitor that from outside. We don't have to send at any point in our operation do we have to send any personnel into a confined space.
Okay, and how big an entryway do you need to be able to get for your bigger tanks, for instance?
So on the larger tanks, we can go through a standard 600 millimeter diameter manway, which is that's basically on an overground storage tank. That's as small as you're going to get. The range between 600.
So you've never got a problem with access in that sense. You can always manage to get in there. When can I ask a question? When it's actually doing vertical walls, what keeps it attached to the wall?
So on fuel storage tanks, you'd generally only be cleaning the floor and up to the first weld on the walls. So we do all that on the floor. So we have magnetic tracks, which give us traction on steel floors, and we can wash up to the first weld of the tank from the floor.
I see, and now I understand it. I had this image in my head of things crawling up and down walls, but it's predominantly to do with the bottom of the tank.
Yeah, to do it with the floor and up to the first weld.
Okay, so what you're saying now is potentially this takes the need away from putting people inside these tanks. I mean, how dangerous is that activity?
Well, I suppose across Europe, to give you an idea on figures, across Europe, there's 200 people every year killed in confined spaces. Approximately 60% of that is people going in to rescue someone who's went down in a confined space. So as you can imagine, if we're working together and you see me inside a tank and I'm after collapsing, your first reaction is to jump into the tank. Yeah. You can't see gas, so you don't see what the problem is. You jump into the tank, you want to get me out and get me to safety. Unfortunately, 60% of them people actually end up in a bigger problem than the first person that has went in, because their breathing's heavier when they're going in trying to rescue someone. They're panicking, trying to get the person out. So,
and is the technology you're providing, is it unique? Is it something that you do differently from other people?
Well, I suppose there's a lot that we do differently. There's a couple of companies across the world. There's probably 4 or 5 companies across the world that's providing different versions of what they call no man entry tank cleaning, and invariably what we're hearing across the industry is they're spending maybe 15, 20, 30% of the time with personnel inside the tank. What we're offering is 100% no man entry. We don't go into the tank.
So that's your kind of unique point here. You know, irrespective of what else you do not have to put people inside that tank if you hire your services.
We won't put people inside the tank, even down to we have had this issue, and I don't mind being open about it. We have had a breakdown with the robotic equipment inside a tank, where we've had to retrieve the robot from the tank without getting into the tank. So what we have is an umbilical system going to the robot, which we can connect on to from outside the tank, right, and pull the robot out of the tank. We've had to do it once in 14 months. We've had to do it once, and we have done it from outside the tank.
So to put some perspective on this, if somebody's got a large storage tank and they want to use your equipment and your systems, how long would it take them to clean a tank typically?
It's very hard to say that, because if you take a white oil tank, just take typically a white oil 30-meter diameter tank, we'd clean that.
What do you mean by white oil? Sorry.
Say your diesel, your kerosene.
Okay. Yeah, refined products. Yeah.
Yeah. So we clean that in 1.5 to 2 days. Okay. No problem. If you go to your crude oil tanks, say we're at the moment we're looking at a project where it's a 105-meter diameter crude oil tank, you're probably talking about realistically 6 months.
Okay.
So that's the difference in time scales depending on the product.
So having 1 or 2 units doesn't sound like a lot in the market at the moment. It sounds as though there's a potential to have many, many more units being busy doing tank cleaning in different countries.
There certainly is. I suppose the industry, prior to our arrival on the scene, I suppose the industry had tried some companies and weren't satisfied with the fact that they were getting anything between 50 and 70% no man entry, but you were still having that 30%. I suppose the industry didn't see the value in investing in something like that, where now that we have arrived with and we have proven 100% no man entry, industry is really starting to embrace that now, which it's a good complaint for us to have, because it's really putting us under pressure to ramp up and to get more systems on the road.
Okay, that's good to hear. So in terms of the size and shape of the company, where are you on your journey?
Well, I suppose the company itself is only up and running about 14 months now at this stage. We have one system fully operational. We have a second system which, if we hadn't have been dealing with the COVID-19 epidemic as we are, we would have that system on the road. It is about 3 weeks away from being ready. So by mid-June, we'd expect to have our second system on the road. We're talking to a couple of different companies in the oil industry where they're looking for us to roll out across 7 different countries across Europe at the moment. So that's really going to put the skates to get us moving with it. Where we see ourselves, we will keep supplying equipment as much as the industry demands, and that's what we've said from the outset. As much equipment as the industry demands, we'll keep supplying it. So we're well on the road. We're well on track with our business plan. We had our plan from the start was that we'd introduce at least one new system each year. We're on track with doing that. By the end of this year, we'll probably actually have our third system in, which will be 3 systems in 18 months.
Excellent. Well, good luck on that journey, Fintan, because anything that prevents people, putting themselves in jeopardy, or worse still, succumbing to asphyxiate inside a tank has to be something that's beneficial. So good luck on that journey.
It is, and as I say, the oil industry up to now, I don't think that we're embracing it, because there was companies out there talking about no man entry, but they weren't providing that. They weren't providing the service, and it left, when we came on the scene, it left a lot of the larger oil companies a bit cold to the whole concept of no man entry, because there was the attitude of, we have tried it, it doesn't work. We have proved it does, and we have proved it with the oil majors in the UK. We have proved 100% it works. There's certainly going to be instances where you have heating coils on the floor of a tank that it's not, you can't have 100% no man entry. Before we take on a job like that, we'll explain the ins and outs of that. We're an honest company. It's one of our core values is honesty with our clients. We'll explain 100% what we can do and what we can't do. We won't take a job on that we're not fit to complete exactly how we say.
Okay, if I had an oil tank, Fintan, I'd be coming to you to get it cleaned, but I don't.
Hopefully.
Good see your journey. Thank you very much, Fintan. Cheers now.
Thank you very much. Thank you.
So I'm delighted that I've got Brian Atchison with me from Safe Influx to talk a little bit about what he's up to at the moment. How are you, Brian?
I'm fine, and great to see you again, Bob.
Good. Brian and I go back a long way. Many years ago, we used to play rugby together. Not a lot of people will know that. One of us ended up getting all ugly and damaged, and the other one is Brian. So let's talk a little bit, Brian, about Safe Influx. For people who don't know who you are and what you do, set the scene a little bit. What are you doing?
Good. Well, thank you for the opportunity, Bob. Appreciate that. So the oil industry, the upstream part of the oil industry, a key part of that industry is managing major accident hazards. And unfortunately, our industry has several of them. One of the major accident hazards is that of managing well control events. And a well control event is when the pressure that has been generated by Mother Nature needs to be appropriately managed and handled by the drilling team who are drilling or completing a well.
And if it doesn't, presumably it can lead to a very dangerous situation like the Macondo situation in the Gulf of Mexico.
That's exactly right. And the Macondo situation was particularly tragic, where there were 11 fatalities. There were 4 million barrels of oil spilt into the Gulf of Mexico, and the total loss of the Deepwater Horizon drilling facility. So that's the kind of biggest tragic example, if you like. Yeah. So that risk of managing the well control event, that has been managed by a team of highly skilled individuals who are based on the drilling facility. And for 100 years, that risk of identification of the hazard and then going through the process to safely close in the well by closing a piece of equipment called a blowout preventer. That has all been down to a human being being able to identify the issue and then go through a decision-making process and then go through a series of fine machine controls in order to control the equipment and make the situation safe.
And presumably because there's humans involved in that, it can sometimes go wrong. The decision's made incorrectly or it's too slow.
That's correct, Bob. And it's not really the human's fault because it's a very highly stressful situation. The human being is often distracted with conflicting priorities. But what we do know is that over 60% of these very serious well control events are caused by human factors issues. So that was really why Safe Influx started, to overcome the human factors issues associated with well control.
Okay, so tell me, what does Safe Influx provide?
Well, we provide equipment which enables us to use the existing sensor package and the existing rig equipment. And the system that we have enables us to identify the problem, go through a decision-making process, and then using machine controls to control the equipment to make the situation safe. All of that is completely automated. It does, however, give the operator, the driller, the power of veto at any moment through all of this. But the really key feature here, Bob, is that we use automation to overcome all of those human factors issues so that the well is left in a fail-safe position for the drilling team to then overcome the problem and then continue with the operation.
Okay, it's a nice idea, Brian. How do you know it works?
The system, I have to say a big shout out to my co-founder, Phil Hazard. So Phil developed at Robert Gordon University. We have access to the simulators at Robert Gordon University. So using the simulators, we developed a proof of concept model, and then we developed an industrial grade machine in order to execute this. So in working in conjunction with Lloyd's Register, we developed a technology qualification process, and then we tested the equipment on factory and then site acceptance tests, and then we can demonstrate the system works against the simulator. Several months later, in October of 2019, we took that equipment and interfaced it with a real rig, which is based here in Aberdeen at Bridge of Dawn, and we then connected up our system to that real rig and went through a series of qualification testing, which enabled us to get a technology qualification extension for that system work, not just in a simulated environment on a cyber rig, but also on a traditional rig. And it was an extremely successful and effective field trial.
Okay, so to the extent of how reliable is it, have you got any estimate or any facts round about that you could share with us?
Certainly. Well, the heart of the system is a series of basically two computers running, but these are very, very high specification computers. And in order to do the technology qualification, we had to conduct a failure mode effect analysis. So the heart of the system, it's just a straight calculation of how reliable the equipment is. So we have a master-slave system operating, and the mean time between failure for the heart of the system is one failure in every 20,000 years. This is a very reliable system.
It may be reliable, but I suppose my question is slightly different, Brian, is to the extent that it picks up the right signals and takes the appropriate action, how confident are you that it gets that right?
Well, as I mentioned earlier, we use the rig's existing sensor package. So at the moment, we have a minimum viable product, but looks at just one sensor, which is the flow rate coming down the flow line. So in the nuclear industry, we typically have up to 3 sensors looking at a specific value.
Yes.
We're not quite there yet in the drilling industry. So our system looks just at that single value at the moment. However, because we're automating this, we have the ability to run quality assurance checks on that signal that will be able to provide warnings or alerts to the operator that the signal's healthy or it's not.
Okay, good. And in terms of how ready you are, how soon before you can actually begin taking this to potential customers to improve their drilling safety?
Well, we're good to go, Bob. We have a system which is ready to be deployed in the field. Although I think we need to recognize that this system is a radical departure for the industry, because that element has traditionally been only managed by human beings. So it's a bit of a step forward for the industry, for both the operator and the drilling contractor community. So at this time, we're currently working with 3 super majors and also a national oil company based in the Middle East, and also a tier 1 service provider to take this technology into the field. So whilst we don't have one in the field yet, we think that will be imminent.
And presumably once you get one in the field and people are comfortable with it, then that makes the subsequent introduction of others all the more easy.
Absolutely right. Again, it's a very high-risk industry, which means we end up with very risk-averse behaviors. And one of those strongest risk-averse behaviors is everyone wants to see it field-proven first. Yeah. So once that's field-proven, then I think the doors will open, and we'll have.
Kind of ironic, though, Brian, isn't it? You're trying to reduce risk, and it's risk aversion that's potentially slowing the introduction into the marketplace.
Absolutely right.
Just so that I can get a picture of what the device does, Brian, how quickly, in response to detecting that flow signal that you said was the critical measure, how quickly would the system then decide there's something wrong here, let's close in the valves and stop the well turning into a big blowout situation?
Well, it's a great question, Bob. We've actually done trials with real drillers down at the simulator suites that we have access to. And when the drillers know that the issue is coming, then we measure how long it took for them to make the situation safe. We then train them in the safe influx system, and then we measure how long it would take them for the system to be safe. And in that simulator environment, bear in mind, when they know that the issue is coming, our system is 5 times faster. Now, if we apply this in the field, one of the issues is the failure of the driller to recognize the problem. Sometimes that can go on for days, for hours and hours, which means our system is infinitely more efficient.
Yeah, okay, Brian. Listen, good luck with that, taking it into the market. Anything that prevents the potential loss of life and makes the industry safer has to be welcomed. Thank you very much for your time, Brian.
Thank you for the opportunity. I appreciate that.
I hope you found that really as interesting as I did, having the conversations in the first place. Have a look out for the second in the series of these 2 podcasts. Thank you.
Thanks for listening to OGV Podcasts. For more energy podcasts, energy news, TV, events, and much more, visit www.ogvenergy.co.uk.